questions, please submit them in the chat feature. We will respond to those. It is a moderated chat, so we will respond to one question at a time. So just not to get as confused with all the questions coming in all at the same time. So we will answer them. If you submit them, I promise, just submit it once and we will get to it at some point. So again, I want to pass it off to the hybrid crew, Formula Hybrid crew, to get started.
Okay, guys, welcome. I'm Yasmina Muftich. I'm the principal team lead of Rensselaer Formula Hybrid. So this is just kind of an introduction into all the stuff we do. So I know by the name it says Formula Hybrid, but this year we've actually done an electric vehicle. So that's a public service announcement there. So you guys all know that ahead of time and don't get confused. But basically the gist of it is, here's a picture of our team last year at Comp. This was during finals week, so you notice there's not a lot of people there, but that's because the rest of the team was taking their finals. Basically, throughout each year, we design and manufacture vehicle components from scratch, and we're all about developing our own proprietary technology, getting hands-on experience, and getting cross-exposure to engineering fields. So a little bit about, the competition we compete in. It occurs every spring at New Hampshire Motor Speedway. It involves teams from all around the world. We're based in New York, obviously, but we have teams from across the country, and we also have teams from Canada, India, occasionally Turkey, and that kind of thing. And specifically about the events in the competition is there's 2-3 days of rigorous technical inspections. So that's pre-electrical, mechanical, and electrical. That's just where they look at the car and they're like, okay, did you actually meet the rules? Does it spec out? Is it going to be dangerous to drive? Are we allowed to let you, compete in this competition? And the car is deeply critiqued and tested. And this is where we demonstrate to the judges that we actually know what we're doing and we have a safe, functional car. So various tests. There's the tilt test, where the car is inclined and makes sure there's no fluids or anything sketchy happening there. The brake test, self-explanatory. Do our brakes work? Does the car actually stop? Driver ejection test, that's making sure the driver can actually get out the car egress in a specific amount of time just for safety reasons. And there's also design presentations, where we present our design, talk about that kind of thing. Project management presentations where we talk about the management side of things. There's dynamic events, which I know are the most interesting to a lot of people coming into this, just since we actually test the car in that sense. So acceleration, 75-meter stretch, where you just go as fast as you can to measure the car's maximum acceleration. Autocross, which is like a complex race course. And then endurance, which is a long 44-kilometer racetrack where you test the efficiency in your accumulator design, essentially. So a little bit about how the team structure is divvied up. So we have 5 main sub-teams, and then I'll go into all of these later. So this is just the general, suspension and chassis, powertrain, grounded low voltage, which we refer to as GLV, and then Aero Body Kit and project management. So suspension and chassis, that's basically, if you don't know what suspension is, it's responsible for the main structure of the car, and it's composed of all the tires, the springs, shock absorbers, and all the linkages that link the wheels and allows the link vehicle to the wheels and allows relative motion between the two. So design work, the chassis, that's like the frame of the car essentially. So that's actually pictured in the top left. We have a team member welding the chassis there, so that whole red part, that's all steel members that compose the chassis. And then we also have brake components included in this technically, so that is also included as well. And then we also have designing of the suspension geometry in MATLAB, which is a software you'll get to know all about if you go to RPI and study engineering. There's also the manufacturing side of things, which is very alluring to people who want to be in this sub-team, since suspension involves a lot of manufacturing time. So you get hands-on experience learning about all the different machines we use, the lathe for turning down metals, the mill just for a bunch of stuff. So yeah, that's all suspension and chassis. And then powertrain. So a lot of people ask, we have a lot of people coming up to us saying, oh, you guys are Rensselaer Formula Hybrid FSAE. What's the difference between you and Rensselaer Motorsport, which is another FSAE team on campus? And this is like the main difference. Rensselaer Motorsport is a car that's not electric. They have an internal combustion engine, and we have an all-electric powertrain. So that's a lot more complex in that we have a battery pack. Last year we had 4 motors, so different in that regard. And here pictured, that's a close-up in the background. It's one of the front outboard motors, and then over here in the foreground is the same thing but in CAD. So there's that. And then this is the main source of power for the car, the battery pack. So I don't know if you guys know, but Tesla Model X and S use the same cells we use in this pack. So these are these pink little things in the top right corner. I don't know if you can see them that well, but those are Samsung 18650s. It's just a slur of numbers that refer to its dimensions, and it's like a part number basically. You can Google it to find out more if you want to know about that kind of thing, but it's really cool to get that experience that actual car companies are using the same cells. And I just wrote many sparks because it's a lot. We have last year we designed it to be around 100 volts peak. So if you don't know what that means yet, it's a lot. So that's that. And then onto the grounded low voltage side. So as I said before, this is just GLV. So this is anything below 12 volts, so low voltage. And that's just circuitry, PCB design, safety kind of shutdown circuit. So we have a bunch of big red buttons on the car, and then if something goes wrong, we push them, and then we're like, okay, car stopped, everything's shut down. And then we also have pre-charge, which protects important components, when voltage surges, and then we don't want anything to break, so that's for that. And then we also have a telemetry system, so that's just receiving and sending a bunch of data around the car. It's kind of like the brain of the car, just sending a bunch of signals. We have sensors for encoders on the pedal box, measuring the rotary information. Yeah. And then if you have a bunch of questions about that regard, I know there's some stuff you might not know, so feel free to ask. I'm just going off onto the technical. So there's also Aero Body Kit, so that's just pretty straightforward. It's the actual, outside of the car, like all the top stuff is analysis. So measuring how air flows around the body of the car, trying to optimize that. All the aerodynamic devices. So computational fluid dynamics, if you go into aerospace engineering at all, you won't learn it unless you take the class, but it's pretty important to get that understanding of how airflow goes around, and CFD, which is the shortened version of computational fluid dynamics, is the way to do it. So if you're into that kind of thing, this is the sub-team for you. And then there's also, it's not just engineering, there's also a huge project management side to things. This is the sub-team that makes sure everything actually gets done. So it's all nice and dandy having the engineering side, but we really need people to actually manage all that stuff and put it together and make things happen. So, if you're not really into the big technical tasks, but you still want to contribute, this is a great way to do it because, we're always looking for more project management people. We never get enough. We definitely need more help in that sense. So project management, you're just responsible for keeping up with the team, making sure we're on schedule, preparing documentation, that kind of thing. And it's a great way to get a look inside the team without, requiring a massive time commitment in that sense. But yeah, that was a summary of the 5 sub-teams we have. So I guess overall what you gain, a valuable experience. If I never joined this team, I wouldn't know half the stuff that I know currently. There's just some stuff that you don't teach in class, especially hands-on technical skills. So there are classes that teach you, how to use basic machinery, but you never get to see your design turn into an actual physical object. So it's really cool to get that experience. A lot of employers and stuff, they stress design for manufacturing, design for assembly. And it's hard to get that experience in class because, in CAD you do this like arbitrary design, and then in classes you have, arbitrary concepts, but through this team you actually start from square one and then see it through the full design cycle. So that's really cool. And then aside from that, friends and a good time as well. I've met incredible people on this team, so everything about it is invaluable. So yeah, but that's the gist about our team.